a hyperbola here. Let's see though, I've got x squared. I'm going to write minus 8x first so that I can complete my square there. Minus 4y squared, and then plus 16 is equal to 0. So I've just grabbed my 4y squared and my 8x, brought them to the left, and put them in an order that'll be beneficial to me. I'll complete the square here. So I do that by half of negative 8 is negative 4, squared is plus 16. And again, if that 16 is already there, I'm just going to steal it. And so this turns into x minus 4 squared minus 4y squared equals 0. For this to be a hyperbola, I need this to be equal to 1 on the other side. And it's not, and there's no way that I can get it to be. And therefore, this is a degenerate conic section, because I can't turn it into a hyperbola. Right? So what I am going to do, though, is I'm going to add this 4y squared to the other side, and clear off a little bit of room here, and we'll work again. Because I can't turn it into a hyperbola, that doesn't mean that there's not solutions. So x minus 4 squared is equal to 4y squared. That's essentially what I've simplified this thing down to, but I can take the square root here, and I'm going to take the square root here, and I need a plus or minus on one or the other, so I'm going to put the plus or minus on the left. So that gives me a plus or minus x minus 4. I'm going to leave it in parentheses because the plus or minus applies to the whole thing. Equals, and the reason I put it over there is, well, you'll see why in a second, I believe. But this equals 2y, and if I divide everything by 2, then this is plus or minus 1/2 times x minus 4 equals y. And what I have here is two lines, two intersecting lines, right? So it's almost like the asymptotes of a hyperbola, except this is the solutions, right? And so there are solutions, but they're not a conic. They're not parabolas, they're not hyperbolas, it's not an ellipse. It's just these two lines. One with slope 1/2, one with slope with negative 1/2, right? Who has a point at 4, 0. So you could actually find that 1, 2, 3, 4, it's there. One has a slope of 1/2, one has a slope of negative 1/2. Those two. That's my solutions. Okay, let's see. Let's look at 11. B. So I have 9 times x minus 2 squared equals 27 minus 3 times y minus 5 squared. And we want to state whether it's a parabola, ellipse, or a hyperbola. Okay? So I'm going to take this term and just add it over. So that would be 9 times x minus 2 squared plus 3 times y minus 5 squared equals 27. I have positive x squareds, positive y squareds, but they have a different coefficient, so it looks like it's probably going to be an ellipse. So I'm going to divide everything by 27 so that this whole thing is equal to 1 on the right-hand side. This turns into x minus 2 squared over 3 plus y minus 5 squared over 9 is equal to 1. It is indeed an ellipse, centered at 2, 5. My minor axis has a radius of 3. Well, sorry, root 3 times 2, right? And then my major axis has a distance of the root of this, which is 3 times 2, so 6. Right? And I think that's all they ask on that one. Yep. Okay. Let's look at 12. 12 says the 8th term of an arithmetic sequence, so that is to say A8. The 8th term is 16, and the 18th term is 56. Okay. And we want to find the sum of the first 20 numbers. So the 20th partial sum. Okay. So I can say that this 16 is equal to sum first term plus 1 less than the number, so 7 differences. Right? And likewise, I can say this 56 is that first term plus 17 differences. And so if I take the bottom equation and subtract the top equation, a minus a is 0, it's gone. 17 minus 7d, that's just 10d. And 56 minus 16 is 40. And so rather quickly I can see that d is 4. And if d is 4, I can then come in here and say, well, that first equation was 16 equals a plus 7 times, well, d, which is 4. But that 16 is equal to a plus 28. Subtract 28, and I have my a equals 12. Negative 12, that is. And that's all I need is a and d. Because to find the 20th partial sum, it's n over 2, which, well, I'll write it, n over 2, 2a plus n minus 1 d's. But n is 20, so that is to say this is 20 divided by 2. 2 times a, where a is negative 12, plus n minus 1, so 20 minus 1, that's 19 differences, which are 4. Right? And therefore, if I simplify this out, this ends up being 10 multiplied by minus 24 plus 40 plus 76, and then that's 10 times 52, and that is 520. Okay. Let's look at 13. 13 is an arithmetic sequence. A guy gets $22,000 a year for a salary, but he gets $450 raises. Every year. So that is to say he has $22,000 the first year, $22,450 the second year, and then $22,900 and so on and so on, right? But it essentially gives us an arithmetic sequence where A is 22,000 and D is 450. Right? And then the question says, find his total earnings for a 21-year period. So using that same equation, n over 2, n is 21, 2 times the first number, which is 22,000, plus 20 times the difference. Right. I'll skip the math here. You can go through it, watch your order of operations and all that. My final answer I got was 556 and 500, I think. Yeah. And one last problem, let's look at number 15. We'll do all parts of 15, A, B, and C. 15 is a little bit interesting, a little bit weird, I think, the first time you see it. But we've got this. For A, I have the sum k equals 1 to infinity of the square root of 2, 1 over root 2 to the k. Right? And you've probably seen a few different formulas for this. There's one where we said, well, we need k to equal 0 for this to work out. But the catch-all formula for this, the one that I use, the sum from k equals whatever, you can start this wherever you want. And as long as it's an infinite thing, right, of something geometric, right, blah, 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 whatever's in here, geometric, right. I always write this as simply the first term. So I write this as a 1 or 0 or 1 with a circle through it, whatever you want to call it. Just put your very first term or the starting term. I call it the start term instead of the first term because sometimes we start with 1 as our first term, or sometimes it's 0 as our first term. Sometimes you have this thing starting at k equals 12 or 20 or whatever it is, right? In that case, just take the very first term and then divide that by 1 minus r, right? And that'll get you the sum every time. So let's take a look at it in this case. That way we don't have to manipulate this and say, all right, well, if this is 0, I have to manipulate this, and then I have all this junk going on. My first term here is when k is 1. But if k is 1, I have 1 over root 2 multiplied by root 2, and that's just 1. And then I have 1 minus r. R is that ratio of 1 over root 2. Right? But I know here that 1 over root 2 is the same thing as root 2 over 2. I might want it in that term, right? Just for fun. Doesn't really matter. What I want to do though is simplify this denominator. So let's just back up. Let's not rationalize that just yet. And it doesn't matter if you do or not. But I'm going to write this then as 1 over root 2 over root 2 to get a common denominator for my 1 minus 1 over root 2. That is to say, I now can combine the denominator, and this is 1 over root 2 minus 1 over root 2. Right? And I can now flip this. So this is 1, my numerator multiplied by the denominator flipped upside down is root 2 over root 2 minus 1, which is just root 2 over root 2 minus 1. I don't need that 1 anymore. And if I rationalize the denominator now, I have root 2 plus 1 multiplied to both of these. I have to distribute. The root 2 times the root 2 is a 2. Root 2 times 1 is just root 2. And in the denominator, I get a root 2 times a root 2, which is a 2, plus a root 2 minus a root 2, which cancel out, and then minus a 1. And so this is just 2 plus root 2 over 1, or just 2 plus root 2. Okay. Let's look at B. B says something close. It's the sum of, now we're starting at 0 to infinity of root 2 times 1 over root 2 to the k. Right? So it's almost the same thing, except I'm starting at 0 in this case instead of 1. But I can go through the same process. I can still say the very first term, which is when k equals 0. But if k is 0, anything to the 0 is 1, so I end up with just 1 times root 2. That's just a root 2. Over that 1 minus 1 over root 2. And I'm going to pause here because we saw 1 over 1 minus 1 over root 2 in our last problem. And this turned into root 2 plus 2. Right? But that just means that I'm taking what I already had and just multiplying it by root 2. So I'm going to just skip all of that math. I'm going to say I'm going to take my last answer and simply multiply it by root 2. Root 2 times root 2 is just 2. Root 2 times 2 is plus 2 root 2. So a little cheating, but this problem is a little more difficult than you would find on our exam 3, I think, or the final exam. Especially with this root 2 in there. I think that's taking it one step too far outside of what we're really trying to accomplish. But you should just be aware that sometimes you can kind of cheat your way using stuff that you've already done. Right? So let's look at the last part of this, 15C. Which says, find the sum of 4 over 9 minus 8 over 27 plus 16 over 81 minus 32 over 243 plus, and it goes on forever, right? So you might be saying, how in the hell would I do that? The easiest way is to take this sequence and turn it into a summation notation. I can see here my R, if I take any one of these numbers and divide it by the previous one, R, the ratio is negative 2/3, right? That is to say, take 4/9 and multiply it by negative 2/3, and you get negative 8/27. Which, if you take that and multiply it by negative 2/3, you'll get 16 over 81, and so on and so on, right? So that is to say, I have a negative 2/3 to the k. It's a summation, and I can do one of two things. I can put a multiplier in here to make this work out, or I can say, bag that, I'm just going to start it at 2, because that'll make it work for me, right? If k is 2, I get negative 2 over 3 squared, which is a positive 4 over 9, so I don't need an a in here. I just start at 2. And I can use that same formula, noting that my very first term is actually k equals 2, which is 4/9. And so I get 4 over 9 divided by 1 minus the r, which is negative 2/3, which is to say plus 2/3. And so this is equal to 4 over 9 over 3/3, right? If I call this 3/3 instead of 1, that gives me 5 over 3 altogether. And that's equal to 4 over 9 multiplied by 3 over 5. The 3 and the 9 simplify, so that gives me 4/15. And we're done. Hopefully this is helpful for you. Your test is Wednesday, so make sure you get on there, take your test, and do your best, and then we'll get ready for the final. And I'll see you for a review for the final.